Okay, now when it comes to the programming, we are going to learn about the programming language called Pascal. And before we going to learn about the programming, we have to learn about how we are going to analyze a particular problem, right? Because uh, the creating a program means that you are going to give a solution for a particular problem, right? So to give a solution to a particular problem, first we have to analyze the problem, right? So analyzing means you have to determine what are the inputs that needs to solve this problem and what should be the process or the processors, and then how the output is going to be, right? So in most of the cases we have the idea about the output. The only thing that we need to figure out, like, what are the inputs that we need and how the processing should happen, right? So to take those examples to clarify the analyzing the problem, in your book they have taken several different examples. I'll go with the very first one. So the problem one is about, like, preparing a letter which can be posted, right? A simple practical problem which we do in normal life, right? So as an input, they have identified a sheet of paper suitable to write the letter on, and a pen and an envelope and stamp and the glue, right? So these are the things that we need to prepare this particular letter. And the processing is going to happen, like, write in the letter. That is the very first process that we are going to do. And fold in the letter and put it into the envelope and paste in the envelope. Then write in the recipient's address on the envelope and stick in the stamp. So we will be getting the output which can be posted, right? So there are some processes which we need to be done one after the other, right? If you consider about these things, no any steps or no any processes can be done together. We can't fold the letter meanwhile we are writing it, right? So that's not possible. But we can change the order of some of these things, right? Like, someone can come up with a different order, right? Like how? Like, someone can say, okay, I'm not going to write the letter first, and I'm going to stick the stamp first, right? He can stick the stamp on the envelope. No, doesn't matter, right? And later he can write the recipient's address, right? Then they can do these things, right? You can go with writing the letter. Next, you can fold it and put it into the envelope. And here you can paste the envelope, right? So the same output will be generated, a letter ready to be posted, if we go on this particular manner as well, right? So that means for a particular problem, there can be many different solutions, and it can be achieved in many different ways as well. The only thing that we need to consider or to be very careful of is, like, we have to be keen enough to recognize or to manage the time which should be efficient in our particular scenario, right? So if we can manage the particular process in different ways within the same time, so it doesn't matter which way that we are going to solve the problem, right? So in this case, so the writing the recipient address on the envelope and sticking the stamp will take the same time. And then you can spend the time of writing the letter, and then you can fold it and put into the envelope. Same time, paste in the envelope, same time. So even though it doesn't give any like like neither of the methods are better than any of those. They are working in the same way, right? If you go on this particular order, let's think it takes 10 minutes. So if you are going on the next particular order, it costs you the same 10 minutes, right? So no, it doesn't matter which way that we are going to solve this problem. Either the way are going to give you the best output or like the efficient output, right? Okay. Now, when it comes to the next example, which they are explaining here, which means the cup of tea, making a cup of tea, right? So they just talking about as the inputs, tea leaves, sugar, hot water. Those are the inputs that they have taken. They are just talking about a plain tea over here, not a milk tea, right? So putting tea leaves in the strainer, pouring hot water to the cup through the strainer, and adding some sugar to the cup and stirring it well with spoon. Then it says testing for taste, taking a small sip from the cup. If the taste is not satisfactory, go to step 3 and repeat steps number 4 and 5. Now, this particular example is different from the above one, since due to a particular condition, we have to repeat several different steps, right? So this will be done once, this will be done once, and when it comes to here, add in some sugar, then stir it well, then test the taste, and condition is if the taste is not satisfactory, then it's going to do these three things again. Add in a sugar, stir it, taste it. Then again, if the taste is not good, add some sugar, stir it, taste it. So in the third time, if we satisfied with the particular taste, then we are done. So we got the final output, right? So in the previous example and in this example, they have introduced us two valuable concepts of a particular analyzing procedure or analyzing process. The first one that they are talking about is a particular problem solving scenario may contain some particular steps which are going to happen one after the other, right? So the steps that we do one after the other are called sequence regarding the programs. It's called the concept of sequence, the steps that happens one after the other. And in here, there are several steps which needs to be done like again and again, which we call a repetition. That is another concept that we are talking when we are doing the programming. Sequence is once, and the repetition, or we call it iteration, as the second concept, right? And there is another concept called selection that happens due to a condition as well, but it does not repeat. It's like you are reaching uh, to your school, like if you let's say your school is over here, and let's say this is your home and this is your school. Like from home to school, there are two different paths. You can come on this path or either this path. right? So if a particular student is going to work, and in this particular point, he have to decide whether which path that he need to take. This is not going to repeat again and again, right? So if we choose this path, then it goes here and reach the destination. That means problem is done. Or else it can reach on this path and come to the school. So either the ways, those are called selections. That doesn't have, they are going to do it again and again at the same time. I mean, right? Every day you are going to school on the very same path, but not again and again at the same instance. So likewise, there are three particular concepts for you to learn regarding the programming: sequence, selections, iterations. Okay, are we clear about this, people?
Yes, sir.
Right, great. So let's start writing, and within another 3 minutes, my session is going to end. So please come through the link again, right? I will be here. So we are like conducting the session until 5:15, people, since we had some, since I was a little bit late. Session was starting at 3:45, and we had some interference through the session, right? So I'm going to continue it until 5:15. So please come if you disconnect, right? So yeah, let's go and take down this very simply, right? So yeah, so this is the very first lesson of the grade 11. So programming will be the main heading. Right, so let's have the subheading called analyzing the problem. And let's write about this sentence. So I got less than 1 minute to end the session, people. So please come back when it is disconnected.
Done, sir.
Okay, how about others? Anyone who is still writing this? So if you are done with this, go with the first example. We just write the very first one. That's all. Like you don't need like a lot of things to be written. So let's go with this. Right, I'm moving a little bit upward so you can copy the example. If you miss anything, just let me know, right?
Done, sir.
All right, one is done. How about others? Okay, so we have started the programming lesson uh, at the very last day that we have met earlier. So I was talking about like it is about analyzing a problem, right? So like before we jump into the programming, we should know what is the purpose of programming and why programming is involved, right? And when you are given a particular problem and when you are like working with some particular problem to be solved, first you have to analyze the problem to give a solution for that. Yes, and when we need to analyze a particular problem, we have to determine what are the inputs for that particular problem, and we are clearly having what should be the output because that is the solution that we need, and we have to work out by using these inputs how we what are the things that we need to process to find an output. All right, so I have given you a very simple example which is on your book, right? Preparing a letter which can be posted, right? And these things are considered as the inputs: the sheet of paper, which is suitable to write a letter on, and a pen, an envelope and stamps and glue. All right. So with those inputs, these are the things that we have done. These are the steps that we have went, or these are the processes that we have taken through uh, to have the desired output of ours, which is a letter ready to be posted, right? And as well as I told you, some of these steps, like even though these steps are given like in the order of 1 to 5, some of these steps can be changed their place in this process list, right? So like write in the letter, fold in the letter and put it into the envelope, and paste in the envelope. That should be happen together, at least these two things, right? But again, you can write the recipient address on the envelope very first, then you can stick the stamps, then you can write the letter and fold and put it into the envelope, and then you can paste the envelope. Or else you can do these two, and you can turn the envelope and write the recipient address and stick the stamps, then finally you can paste the envelope. So likewise, for a particular problem, there can be many different solutions, which we call them as alternative solutions, right? So those alternative solutions must produce the same output. That is what we are like expecting at the end of the day, right? So it doesn't matter which way that we are going to approach the final output. There can be many approaches. So what you have to be concerned, what the concern should be, whatever that you are proposing should be the efficient thing, or like the most efficient way of doing it, because ultimately why we are doing programming is to like manage our time, is to like spend little time regarding some particular thing and take the output that we decide. So if it takes longer, or like it takes a lot of time to end, so even though it is providing us the output, it will be a waste of time, or like it will be an inefficient one. So then we refer it as a bad program, or like as a inefficient program, right? So what you are trying to do is you should try to take it in an efficient manner. So if it is done in the optimal efficient manner, or like the very good way in efficient manner, then it's okay. It doesn't matter what is the approach that you are going to do. So if you think about the same scenario, which is same processes, so like writing the recipient address on the envelope and sticking the stamp will take the same amount of time, even though you are doing it after these three processes, or you are doing it these two at the initial stage. So it will give you the same time. It will spend you the same time. And writing the letter and folding it and putting it to the envelope, again, it gives you the same time, right? So it doesn't matter whether we do these two things at the first and do these three steps at the last. It will give you the same time as you do it in the original order, right? So both the answers can be taken as a correct way of like creating a letter which is ready to be posted, right? So we have gone with this particular problem, and in this problem, all these steps are happened one after the other, one after the other. That concept in programming, we called it a sequence, right? There are three types of concepts in the programming, which is sequence, selections, and iterations. So this particular flow or a way can be recognized as a sequence, right? Okay, so under your first problem, it's better we write this particular point. I will read it to you, and you may write it down, right? So you can put a star mark or any particular symbol that you want, and you can say it like this. In the above problem, in the above problem, note it down, people. In the above problem, in the above problem, inputs will be, inputs are processed, inputs are processed one after the other, one after the other, one after the other. Full stop. In programming, this kind of tasks, people, this kind of task is not a very good way of expressing it. I'm sorry. Let's alter the sentence. In programming, this concept, in programming, this concept is recognized as, this concept is recognized as sequence. Sequence. All right. Okay. So with that, I am moving to the second example. That's the same thing in your book, which is making a cup of tea. So this problem gives us another concept of the programming, which we call the iteration, right? So the problem or the challenge that we have to achieve is like making a cup of tea, and it will be much better if you say this, making a tasty cup of tea, right? When you are writing it, it's better you have the word tasty, right? Tasty cup of tea, right? Making a tasty cup of tea. Otherwise, it gives you the incorrect idea, right? So you have it over here, making, I'm sorry, not over there, making a tasty cup of tea, right? Over here, you add the word tasty, right? So here the tea means, people, in Sri Lankan jargon, it's plain tea, right? They are talking about making a plain tea, not a milk tea, right? So like to make the tea, the inputs that we need is the tea leaves, the sugar, the hot water. In the scenario, they have explained it to you, like put the tea leaves in the strainer, pour in hot water to the cup through the strainer, and that will make the tea without the sugar, and add in some sugar to the cup and stir it well with a spoon, and tasting for taste, take in a small sip for the cup, right? So these five steps happens one after the other. That means in a sequence manner, right? And you can realize, if you think about how your mom is making a cup of tea, it can be a little bit different from this, right? So if you take my mom as an example, she first have the tea into a cup, and she pours the hot water into it, and she stir it, and then she used the strainer to filter the tea dust from the plain tea. All right, so that's the way that she's used to do it. And again, it's going to give me a cup of tea. Even this particular procedure is also going to give you a cup of tea. No difference, right? But here, the most important thing is this. They are testing for the taste, taking a small sip from the cup, and look at the sixth one. If the taste is not satisfactory, this particular thing indicates a condition. So we check whether the taste is satisfactory or not. If it is not satisfactory, then it asks us to repeat third step, and as well as the fourth and the fifth. Right? So that is when the taste is not satisfactory. If the taste is satisfactory, we don't need to repeat these things. But if it is not satisfactory, we have to repeat these three. Right? As well as then we have to check the satisfaction again. Right? So you put the small sugar and stir it and take a small sip and see whether the taste is satisfactory. If it is not, we are again going to do these three. Right? So likewise, these three steps will be repeated until the tea, the tasty or the taste of the tea is satisfactory. If it is in the satisfactory mode, okay, then you are getting the output that you are desiring. Right? So what happened is, due to this condition, these three steps were repeating. Right? So that is another concept that we are going to learn through the programming, which we call iteration or the repetition. And remember, if an iteration or a repetition is going to happen, that is happened due to a condition. Some particular condition should be there, and that particular condition should be a particular question which can be answered with a yes or no. If you think about this particular condition, it is asking if the taste is not satisfactory, or in other words, you can ask the question, is the taste satisfactory? If it is no, if the answer is no, then you have to go through these three steps again. Then ask the condition again. If the answer is still no, do this again. Then you can ask this question again. If the answer is yes, then you are getting the desired output. That means in this scenario, due to a condition, there are some steps which needs to be do again and again, which we call a repetition or an iteration of programming. Okay, people, are we clear about this? Yes, everyone, are you clear about the concept which we call the repetition? Okay. Okay, great. Right, let's just write about this second problem. So problem number 2. So say it is making a tasty cup of tea, and when you are writing the output, put the word again, tasty, a tasty cup of tea, right? Not just a cup of tea, right? All right, so copy this down, people, as the second problem. Yes, Dulandi, you may leave it now. Yes, people, are we done? Anyone who is still writing this? All right. So moving forward, and once you are done with this, let's write this point at the below. In the above problem, write it down, people. In the above problem, step number 3, 4, and 5. Step number 3, 4, and 5. Step number 3, 4, and 5 needs to be repeated, needs to be repeated needs to be repeated due to the condition, due to the condition, due to the condition of step 6, of step 6, within brackets, is test satisfactory, is test satisfactory. Full stop. In programming, this concept recognized as in programming, this concept recognized as repetition, repetition or iteration, repetition or iteration. Okay, so I'm moving forward to the third problem. Now look at this. I'm taking you to the problem number 5. No, much better it is this, problem number 7. Now here we can learn another concept, which is called the selection. So this can easily be built up by the any particular program as well, programming language as well, right? So here the problem is finding whether a number is odd or even, right? So how we are going to manage this problem? That means any particular number is given, the program should be output whether the input number is an odd one or an even one, right? So how we are going to do this? We are going to have the number as our input. It's only the number that we want. And we divide the number by 2. And we considering the remainder. If the remainder is 0, then we can take it as an even number. If the remainder is 1, then we can take it as an odd number, right? Then the output is given whether the input number is an even number or an odd number. A very simple task. So what we have to understand is, in the process what we have done, first we divide it by 2 and we take the remainder, and if the remainder equals 0, this is a condition. If the remainder equals 0, then we consider it as an even number. And even though in the problem it says if the remainder equals 1, then it is the odd number. Without considering this, we can determine the odd number by considering this same condition. So like if the remainder equals 0, then it is considered to be an even number. If it is not a 0, then it can be considered as an odd number, right? Simple as that. Right, so that's the way it's going to be, right? So like depending on this condition, we can determine if it is true, it's going to be an even number. That means if the remainder equals 0, it's going to be an even number. If not, straight away it's going to be an odd number. We really don't need to check whether the remainder is equals to 1 when it comes to the even and odd, right? So we really don't need this particular condition. So we can straight away go for the odd if it is not a 0, right? So here, due to the condition, we don't have anything to be repeated, but we have something to select. If the remainder equals 0, we select the even number. If it is not, we select the odd number. That's all. Then the program is done. This concept is recognized as the selection, right? So due to a condition, there are separate paths for the end, right? If it is the remainder equals 0, goes to the even number showing path. If it is not a 0, goes to the odd number showing path, right? So no repetition, but the selection is there. Are we clear about this, people? Yes, everyone, are we clear about this? Lamai, are we clear about this? Right. Great. So let's write this example by indicating problem 3, not 7, right? This is the third problem that we are going to write in the book. So write it as problem 3 and write this down, right? Right, people, are we done? Anyone who's still writing this? Okay, so let's write the sentence under the note, right? Let's go it like this. In the above example, no, not the example, people. In the above problem, the output, the output, the output will be, the output will be differentiate, the output will be differentiate due to the condition, due to the condition due to the condition specified in the process, specified in the process. Within brackets, is remainder equals 0. Is remainder equals 0. Full stop. In programming, this concept is recognized as, selection. This concept is recognized as selection. All right. So the three concepts that needs to be done in the programming is such. Right. So now we are moving the ways that we can represent a solution for a program to be illustrated. Right. So like when a program is given, or like when a particular problem is there, when we are recognizing what's the solution for it, there are certain tools that we are using. So as in the initial stage, we recognize like what is going to be the inputs, what are the process, and how the output is going to be, like we have done over here. But in the practical world, in the software industry, if we are given a particular solution to be done, or like if we are given a particular problem to be solved, then we should illustrate what is the way that particular problem is going to be solved. And in programming language, in programming field, we call this an algorithm, right? So an algorithm in programming jargon, it says a method to show the steps in solving a problem. So it's a programming jargon, people, right? So like programming වලදී තමයි අපි පාවිච්චි කරන්නේ වචනේ algorithm, right? We can even use it in the day-to-day life, but algorithm goes mostly with the programming jargon. So when we are illustrating a algorithm, when we are illustrating an algorithm, there are two ways that we can introduce that, or like the way we can illustrate it. One way is illustrating the solution in a graphical mode. We call that graphical mode as flowcharts, right? So if we are illustrating a particular algorithm using a flow chart, that means we use several different symbols, and that particular symbols will illustrate how to solve that problem from beginning to end. And there is another way that we can introduce the particular algorithm in textual form, in text, right? So if we are present, if we are illustrating the algorithm in textual form, we call it a pseudocode, right? Pseudo means not genuine, right? So like a code that we are creating using a programming language like Pascal that we are about to learn is called a source code, or just a code which can be executed using a particular application, right? But pseudocode means there is no application for a pseudocode to be executed. It is just a set of instructions which is explained in text, right? Like one after the other, right? So two specific methods, pseudocodes and flowcharts. Flowchart is the graphical representation. Pseudocode is the textual representation. All right, so let's first write about the term algorithm. Then we'll come to the pseudocodes and flowcharts. All right. So yeah, have this heading, people: problem solving using algorithms, and write down the part that I am highlighting to you. Right. Okay, people, are we done? Can we move forward? Anyone who is still writing this? Okay, moving forward. So then we can mention about these things. Now look at this. The concepts that I have told you, the sequence, selection, and repetitions. Right? So let's write about the control structures in this manner. Right? You don't need to write any subheading regarding this. I'll tell you what to be written. So let's go it like this. Like you can write this sentence as the second point under the same topic, right? So which means you are under this topic, problem solving using algorithm. So the first topic indicates what is an algorithm. Then as a second topic, the one that I'm going to read you, right? So the second topic goes like this. When an algorithm is illustrated, when an algorithm is illustrated, it will use, it may use, it may use, it may use, it may use the above mentioned concepts. The above mentioned concepts within brackets, sequence, comma selection, and repetition. Within brackets, sequence, comma selection, and repetition. Full stop. These are called control structures. These are called control structures. Right? These are called control structures. I'm not going to explain them again and again because we have clearly talked those things in our problems. Right? So just mentioning this is enough. Then all right. So here it's explain what is sequence. We already know the instructions, what happens one after the other. There are selections, right? So this is the selection. Right, and a selection means like due to a condition, our path will be deviated into one particular way, right? It's not going to do an iteration. It is like direct into a one specific way. Like there will be two paths. So due to the condition, we will be choosing one particular path, which we call the selections. And when it comes to the iterations, due to a condition, the sum of the steps, one step or many steps, will be repeated again and again. And when that condition, like on the other path of the condition, it will leave the iteration, right? In one path, it will be iterating, and on the other path, it will leave the iteration, right? So likewise, these things can be taken as the control structures. Okay, now we are come to the point where we are going to represent or illustrate the algorithms. So like I said, there are two ways that we can illustrate an algorithm. There are many ways that we can illustrate an algorithm. These are the two famous ways that we are talking, which is the flowcharts and the pseudocodes. So flowchart is considered to be the graphical representation, and the pseudocodes are considered to be the textual representation, right? So yeah, let's straight away. Let me see whether we need to write this thing. Yeah, it's better. It's better we write this thing, right? And under the same topic, we are still under the very same topic which we have written, like at the beginning, like over here. So this is the first point, and I read you the second point about the control structures. Now I need you to write the third point under the same topic. So the third point can be represented like this, right? So write this as the third point. So it will show you like what are the ways that we can represent the algorithm, like using flowchart and pseudocodes. So the third point. Okay, people, are we done? Anyone who is still writing this? Okay, right. Now we are coming to a main topic which we call the flowcharts. So now is the time that we are going to learn how to represent an algorithm in as a graphical representation. So like I said, there will be several different symbols, and there is a purpose of using these symbols during the programming, right? So we use these things to represent the flowchart. So let me introduce these symbols to you at the very first, right? So in the flowchart, like when it comes to the flowchart symbols, we use this is not a rounded rectangle, people. This is an oval, right? So we use oval shape to indicate the start and the end of the flowchart, right? So let me take the tool that I'm using to draw the flow chart, right? Even you can use this application. This can be downloaded from the Windows Store for free of charge, right? Right. So we use the oval shape like this, people. So to indicate the start, we use an oval shape and we indicate start. We write the word start at the beginning of the flowchart, right? And as well as to indicate the end, somewhere that we are going to end the flowchart, we just draw the oval shape at the end. And don't mistake, like, or don't get wrong that first I should specify the start, then right away I have to indicate the end as well, right? I'm showing this because it's the same shape that you are using, right? මේ start එක දාන වෙලාවෙම end එක කොහේ හරි ලියන්න ඕනේ නැහැ. එහෙම දෙයක් නැහැ. We started by putting the start, right? Then we use the flow, right? To indicate to which direction that this flow chart is going to flow. And as well as if we want to indicate an input, we can use a parallelogram. And inside it, we can write any particular text to indicate what's that we are going to input, right? So as an example, like if you take a very simple, like a random example, let's say the computer needs a number. So we can say input a number, right? So when you are indicating the input, right, that particular text should be associated with something like this: input, or you can say enter a number, or you can say obtain a number, right? These kind of words can be used to maintain or like to indicate that you are inputting, right? So either input or enter or obtain, or as well as you can say get, the word get, that can also be taken, get. Right? Doesn't matter. Right? So you can use any kind of word to indicate that this is an input. And if you are going to output something, you can use the same symbol to indicate the output. So when you are saying output, you can use output, display, right? That kind of words. So display the total, if we are about to display a total as an output, right? So likewise, right? So likewise, you can indicate your inputs and outputs using a parallelogram, right? And another advice, people, when you are drawing, so you have to draw these things on your board. When some problem is given, you have to draw your flow chart. We are going to do those kind of exercises here. So when you are writing any particular inputs, outputs, in the very near, we are going to talk about the processors as well, right? So when you are writing those things, you better write things, or like you better write your input process or the output first, then you use your shape to go around what you have written, right? Or ලියන එක ලියලා shape එක අඳින්න. Don't draw the shape and write things inside it. The reason is, if you are doing it like that, sometimes the space inside the shape will not be sufficient for you to write the things that you need, right? So in those cases, you will reduce your font size when it comes to an end. So it won't be a clear answer, right? So write what you are writing clearly, then you draw the shape around it, right? That is the best practice that you can do, right? And there can be processors during the algorithm. So to indicate the process, what you can use is a rectangle, right? So some particular process calculate the average likewise. So when it comes to the processing part, it's better you indicate what's the process that you are do. Calculate, you can say determine, right? Some suitable verb can be uh, given, as well as you can use some equations as well, right? So like if you are like talking about calculating a total, you can say get or enter or input two numbers, as x and y, right? So like then you can say, like without saying calculation and all these things, you can just, I'll duplicate this because you can see these things clearly, right? So you can say like this, total equals x plus y, right? This kind of a thing can also be represented as a process. Doesn't matter, right? So either the equation way or the textual way, you can represent what you are going to do. But be very sure to indicate or to define that clearly what is x and what is y at the beginning of your algorithm, or right at the very beginning, at the place that you are getting the x and y for the very first time. Be sure to clarify it very clearly. Then you can use it without a problem, right? Okay, so we use the oval shape to do the start and the end. We use the parallelogram shape to indicate the input and output. We use the rectangulars to indicate a process, right? And to represent the flow, we use these arrows, which shows how our flow is going to happen. Now, remember these symbols, which I have discussed so far, can only have one inflow and a one outflow, right? Like start can have only one outflow according to your syllabus, people, right? There are in the practical world, there can be many outflows from the start, but according to your syllabus, we are talking about it can have only one outflow. එළියට යන ගැලීමක් විතරයි. And any other symbol, like any input symbol, any process symbol, that means any parallelogram, any rectangle can have one inflow. So wait, Tat is doing the class. No, Susu, Tat in that. Yeah, sorry for that, people. So, like when it comes to the parallelograms and the rectangles, you can have one inflow and one outflow. Remember, that's a very strict rule as well as one of the golden rules that we use in the flowchart. So, start has one outflow generally, and the parallelograms and the rectangles has one inflow and one outflow. If you take this again, one inflow, one outflow. See, likewise. And there is another symbol called condition box, which we use to write the conditions. And as I told you here, we are going to ask a question. Is x larger than 10? You must have your question mark over there when you're asking a question. And for this, of course, it can have two outflows. This is the only symbol that can have two outflows in your flowchart, right? So it can have one inflow, only one inflow, and two outflows can be there. And on these two outflows, there are indication regarding the condition that we are using, saying yes and no. So that means if this question can be answered as yes, this is the way that you are going to direct. If this question can be answered as no, this is the way that you are going to direct. Right? So this is the only shape that has two outflows. And it can have the inflow from this side or from this side. Using any particular side, you can have the inflow. It doesn't matter. Right? So one inflow and two outflows can be here. Right? So always remember the flows are given or indicating as a arrow, and the arrowhead must be at the end of the line. Right? Don't put it at the middle. Right? Right? Those kind of arrows are not drawn during the flow charts. Right? Arrows which has the arrowhead at the end of the line. Right? And there is a very rarely using symbol called connectors, which in your syllabus, we use it to connect your flow chart. If your flow chart goes beyond one page, if it is continuous from one page to another, then we use a connector which can be given through a circle, right? I'll show you the symbol in over here, right? Like this, right? So we indicate that connector right over here, right? So as an example, I can modify this as a connector by making this a circle and get rid of the yeah. So I'll make this as a connector, and we indicate some particular capital letter over here. So this indicates, yeah, my arrow type got changed, right? This indicates this particular connector is going to start from somewhere else to continue the rest of the part, or the balance part of the flow chart, right? If you consider that I'm having two pages over here, so practically I can show it like this to you. So just assume like these two as two separate pages, right? So I'm using the connector over here. right? So it's like this. So this part, if it is considered to be a one page, and this part considered to be the next page, right? So it indicates how how this flow chart is connected, from where this flow chart is connected. Likewise, you can use the connectors. People, are we clear about the symbols of the flow chart? Yes, everyone, are we clear about this? Lamai, are we clear about the symbols? Okay, great. All right, so let's write about the flow chart quickly, then we can end the session. So have the heading flow charts. It's a main heading, flow charts. And then you can write these two sentences. Then you have to copy the this particular table in your book, right? So put the heading flow chart, write down this particular sentence. Then, yes, you can draw this table at home, it doesn't matter, right? So you have to do the heading and write down the particular explanation, and then you can draw this particular table at home. So we can start drawing the flowchart by next week, right? Some different flowcharts. I'm going to draw you some, and then I am asking you to draw some for me. Then we'll see, right? So finish this, and then you can leave the session. Okay, if you are done with this, we can end the session, people. So please complete the table at home. So we are straight away going to the flowchart drawings by next week, right? So thank you very much, everyone. Have a very good day, right? And I'll see you next week for the very same time to discuss about the flowchart, to draw the flowchart, and be ready with a good pencil and an eraser, right? Be ready with that. So thank you very much, everyone. Have a very good night.
Thank you, sir. Goodbye.
Thank you,
Right,
sir.
okay, people. Thank you very much.
Thank you, sir. Goodbye, sir.
Right, okay, Dua. Right, okay.